Good morning to everybody. Today we have one of the two sections on application of econometric analysis to better understand the root of all the graph and the result that we show and that we study together. And we have the pleasure to have Dr. Roberta Misuraca, which is leading this type of research. That will be recorded and will be put on the Moodle page, revised, also cleaned, and will be put on the Moodle page in 2 days. Okay?
Okay, hello guys. As the professor said, my name is Roberta Misuraca. Okay, we will be together for 2 days. Today we will address some of the most common tips of the basic economic analysis. Tomorrow we will focus on the most important topics in the modern migration economics, such as migration and crime, the economic assimilation of immigrants, and so on. Okay, let's start. Today we will see the introduction, okay, the linear regression fundamentals, so univariate and multivariate regression, cross-sectional approach, time series approach, and inference analysis. Okay. Okay, sorry. Okay, what a regression? Do you know what a regression is?
There are students from law and from
okay.
political science.
No panic.
Some of them have done statistics or economics, but not applied research.
Also, in general terms, do you know? No. Okay, so regression is a dependence between two variables that we assume to be. Before continuing, an interesting distinction must be made between correlation and causation or causality. So correlation is when two variables move in the same on opposite direction but are not dependent. For instance, I don't know, the probability of a storm and how many ice cream I eat. So maybe when it rains, I eat more ice cream, but there is not dependence, no, between these two variables. Okay, causation is when two variables move in the same or in the opposite direction, but the trend of one is influenced by the trend of the others. That is a dependence. Okay. So, okay, given that the regression is a dependent between two variables, and the goal is to understanding and quantifying the linear dependence of two variables. Okay.
Roberta, they have just to be able to read, not to understand. So go ahead with the example with scatter plot.
First step is the usage of graph to understand where there is a linear relationship between two variables. An example of this scatter plot is this figure. So this figure shows the relationship between the share of employed migrants and average weight by region. As we can see, it seems that in the region...
This is Italy.
Yes, this is the share. This is a relationship between the share of employed migrant and the early wage. So it seems that some region, such as Veneto, Friuli Venezia Giulia, Lombardia, Emilia Romagna, present more high early wage. But this is...
You have here Lombardia, you see. Describe the picture.
This figure...
Here you have Sardinia, yes. Basilicata, Calabria, Puglia, Sicily. Okay. Over there you have Lombardia, Friuli, Veneto. Okay. You see. No.
Okay. Okay. So Here we can see the region, the Italian region. So seems that the region in which the share of employed migrants are higher, the early wage are higher, no? Okay? But
Is this a relation, a correlation? We don't know. This is just a fact.
But the fact is that if we'll see the figure 2, so that show the relationship between same share of employee and migrant and the average wage by region in some specific sectors such as manufacturing, construction and hospitality industry. And if we will see the figure number 2 that show the relationship between the share of employee and migrant and the average wage for other industry, we will see that our main relationship is driven by some specific sector. That is that. Okay? So, pay attention because we have a so-called spurious relationship, okay? That is a relationship between two or more variables actually guided by an observable or observable barrier, which, however, we have not considered in our analysis, which therefore can lead us to draw wrong results, okay? That's clear if we will see this figure that show the general relationship
and which you have Sardinia, Calabria, here, Lombardia, Veneto, otherwise don't
yes.
See?
Okay. This region show a higher early wage. Okay. There is other region that present lower early wage. But as I said, this is not a general effect, but this is the effect of specific sector. Because if we will see the figure number 3, the situation is different, no? Because Lombardia, okay, Friuli, Giulia, okay, but other regions such as
Calabria, Sardinia,
Piemonte or Veneto present higher, lower early wage. Okay, so this is to say that pay attention at the spurious relationship. In general,
Calabria has the same wage that Bologna.
That Friuli, Venezia, Giulia.
You understand? Yeah. No? So if you change sectors, which sector? I share my.
This is the general sector, but if we will see at the specific sector in which the relationship is more strong, we will see that Emilia-Romagna stay here, but Sicilia, Molise, Campania, Calabria have a lower wage. So the point is pay attention at the spurious correlation, okay? In general of our hypothesis, okay? Okay, spurious correlation. Okay, if we see these figures show the relationship between the PhD in sociology.
This figure is very famous because this shows how research can be ridiculous and stupid.
Yeah.
Because do you think that the PhD in sociology awarded in the United States are correlated with the worldwide non-commercial space lenses? No.
It's possible, obviously not.
This not correlate, but it's very important to understand that this is so clear that there is no relationship between the two. But many times you have variable which seems connected, And you have to be very clear to see if there is a correlation, a relation between two variables, if the two variables move in the same way. And many conclusions and stereotype of migration are exactly based on this wrong correlation, wrong links between variables, which instead is jumping around the real causes of a phenomenon.
Yes, exactly. Okay. Okay. So the point is, keep in mind that if something doesn't make sense to you, probably it doesn't, no? Key takeaways from graphical evidences. Allora, before using some mathematical statistical tools to evaluate the dependence of two variables, plot the data on a scatter plot. As we So, scatter plot might be indicative of the relationship between two variables. However, an heterogeneity analysis is key to fully understand the characteristic of a phenomenon. Both graph and statistical tools might find a relationship between two variables. However, before plotting and or regressing two variables, answer to the following question. Does it make sense? So, as I said, if something doesn't make sense to you, probably doesn't for
Or
experience,
at least
no?
there is more research to do.
Esatto,
There
investigate
is
it.
more research to do.
So, keep on investigating.
And don't take shortcut, because the shortcut in explaining a relationship can hide a different story, very different story. And many of the newspaper articles present graph correlation, which are based on wrong definition.
Okay, what does linear regression do? So, linear regression fits data in a linear model to show the relationship between independent and dependent variable. The independent variable are multiplied by a parameter beta 1, which shows the average effect of each independent variable, on the dependent variable. So the point is, investigate the effect. Yes.
Take a simple example, which is outside migration field. Age and heights of a person, okay? You have here the age, and here you have the height of a person. You want to understand if the age is related with the height of a person. You have a scale, since always when you are 1 year, you are as tall as like that, the more you grow up, and so on.
Yeah.
This is a relation, causal or not, we don't ask at the moment, but this is the idea that you have a variable which and another one, which can be affected by this one.
Yes.
Outside migration is more complex, but heights, age and heights is one of the traditional relationships that you have in all the disciplines.
Yes. The point is, investigate the effect of this variable on this variable.
So age
True.
on heights.
True, yes. True, the beta 1 coefficient. Okay?
You want to
a
understand
statistical and mathematical method,
Yes.
not to data or
This, forget
no,
it.
okay.
Forget. And this is just to say, fermati un attimo. For instance, every year a person, the height of a person increased by 10 centimeters, 20 centimeters, and beta is exactly this. I have here the centimeter of heights and how much, so the 1 year, it is transformed this in centimeter of height.
Yeah.
Okay? So this is the way in which the research is analyzed. This is the error, the individual error, because each person has a different eye state for individual. And this one instead you didn't mention.
Beta 1 is the
Slope.
the slope
E beta zero?
when is the slope when the x is 0. Okay, so in
So
the
beta 1,
graphical,
beta 0 is the intercept.
yes, is
Right,
the
you said
intercept
beta
when
1.
the slope is 0.
Yes.
Ma posso no, segnare.
No, però hai detto beta 1.
Okay. So now we will see better. Okay, so the goal is to study the effect, as we say, the effect beta 1, if any, of a change in one or more independent variables or explanatory variable on a dependent variable or outcome. For instance, the effect of an increase in years since migration on the individual wages. Okay, we have an example. So this figure shows the relationship between the Italian gross monthly average wage on foreign worker and years since migration in December
Years since
2030.
migration, I don't know if you know what is a variable measure since how many years you have been in the country of destination. Okay? So years since migration, you have been 1 year, 2 years, 3 years, 20 years, 40 years, and 60 years. So the idea is that the more you stay in the country destination, the more your migration is old, the higher will be your wage.
Yeah.
This is a proxy of integration.
Yes, exactly. So what regression does is hypothesize a relationship between this point and provide us with a line because this is a linear relationship that approximate the relationship between the points as closely as possible. That is reducing the error. Consider that
You're reducing the distance from the point
Yes.
to the line.
Esatto, consider that the error are this point, are the distance between each point and the line that is the relationship approximated by our regression. Okay, so imagine that we have epsilon here, no? More the points are close to the line, better is our hypothesis, our research hypothesis.
You can go to the previous slide.
Yeah.
The previous line. If you, no, the previous, quelli a grafico, così vi facciamo vedere un caso dove,
Quale dove andare?
dove c'è il grafico.
Qui?
Solo sopra. Okay, here. As you see, here is very difficult to have a relationship. If you have a relationship like this, all the countries, this is very far, this is very far, this will be very far. So if you use a line inside this point, the difference will be very large. This means that it's very difficult to find the rule that explains the relationship between these two variables. If the distance is very large, it means that your fit is bad. Your fit is very good, if you go back to the slide, if your fit is very good, is this here is perfect. All the points are on the line. But the more you go ahead, the more year you are in the country, the more the fit doesn't match very well the line. And so the error increase. That means that this variable is not fitting very well for a linear relationship. Probably you have to find a square, a different one. But it's terrible. Until here, you see all the points are on the line. If you want to find heights and age, you will find a line which is very, very similar to this one. But after it's become nonlinear, because when you become old, your height incline, so it's not always positive. You grow until 23, and after you stop and you decline. Okay, so the relationship are more complex, but here you see that the error is very small. Here it's increased, it increased, it increased.
This is, for instance, the outlier. So
Yes, and the economists are very brave. Sometimes, this were a country, they say, this is an outlier, I take it off. What does it mean? It means that it's so difficult to find a relationship between this variable that it is is a special case. When you have a class of students, you have one which is much taller than all the others, sometimes you make the average, so you take off the outlier, because otherwise the relation will be distorted and the expectation of the heights of people will be distorted. And the same with social phenomena, which are even more difficult to forecast. So the error is a very important part of the story. If the error is very large, it means that your fit doesn't work. Okay? So, and you have to test another model.
on another hypothesis.
Another hypothesis, yes, another relationship, another variable, that this variable is enabled. And we will show you in the regression the importance of the error and the significance of a variable. It is significant only when the error is smaller than the coefficient.
Yeah. Okay. Before to continue, an important distinction is between univariate regression and multivariate regression. So, the univariate regression studies the relationship between an independent variable and a dependent variable, just one. Multivariate regression studies the relationship between more than one independent variable and a dependent variable. Okay? So
There was
the
age and
is an independent variable and more than one independent variable. Okay, the difference is one independent variable.
yes, the first case was age and heights. The second, you can have age, age, weight, and height. I don't know what you eat and so on. And
Yeah. Okay, this is the formula, but as we say, this is the dependent variable or outcome. This is the independent variable or explanatory variable. This is our coefficient, and this is B0 is the intercept of the line. So imagine, for instance, so okay.
This is 0, but if it was starting
Imagine,
here,
exactly.
imagine.
This is B0 here, so the intercept. The slope here is beta 1, no? The average distance, and all is progression. Okay? Okay. This is for the univariate regression. Okay?
Yes. And this is the error.
This is the error, that is the distance between each point and the line.
And I is the index for the person.
Because
the
this is an individual person. Could be, for instance, a film
region,
person, region,
region, state, country.
Yes.
Do you have any question in the meantime? Because we wouldn't like to lose you. It's very important that this class is useful for you, not for us, we know this thing, but for you. So please, if you have doubts, ask, do not hesitate.
Especially if you want to continue, you know, I don't
Yes.
know, with a PhD, for instance, no? Okay, consider that this is univariate regression. Okay. How to interpret the coefficient? This is very important. So, beta 1 is...
Which is the slope.
which is the slope, yes, is the relationship between the covariance between pi and x on variance on x of x.
For instance, the variance of the age on standardized on the variance of the age, if they have many years, few years, and so on. So of course you have to control like the size of the population and so on. And above you have how the heights varies according to the age, how much they vary together. Standardized of the
Just-
variation of the age.
Just to say the way in which this variable
Move together.
move together. Yes. So beta 0, this is the intercept, is the difference between the expected variable of I minus the coefficient that multiply the expected variable of x. It's
Expected variable, let us say the average.
Yeah.
I take the average age, they are 18, let us say. I multiply this for the coefficient, and I take it off from the average height. This is the intercept. So I take the average of the phenomenon, but this is a technical point, but you understand intuitively that the line.
What is important for you is that, in my opinion, so that beta 1 provide the effect of 1 unit increase in all x on all y's. So the effect of
They become older 1 year.
yes,
How much centimeter they gain?
the effect of this on average. And beta 0 is provides the value of y's when the independent variables is equal to 0. So the intercept binary, okay? So when x is 0, the intercept, I don't know if it's clear. I hope, yes. I don't know. Okay, take a look at this example. So this table shows the effect of an increase in years since migration, so the length of stay, on a foreign gross monthly wage. Okay, in this case,
We have 3,331 observations.
yes.
So we have a large population, and we try to explain only this variable. So we have the wage, and we try to explain the effect of year synchronization on the wage,
Yes,
which is not the only variable that affects wages, as we know.
exactly. And this table tells us that a unit change of the year since migration increase the gross monthly wage by 30 euros, practically, on average. Okay, if the change, for instance, is equal to 2, the increase in the gross monthly wage was 2 times 30
So 26 euro.
26 euro, exactly.
This is, show them that you have 3 star at the error.
Ah, ok, ne parlo più avanti adesso.
Però.
Ok.
Look at the fact
Look
that there are
at-
3
look at-
stars,
esatto.
and there is the one in the bracket is the error.
Yes, these stars
No, because if the
that
error,
can be,
if the error was 27, instead of being 0.781,
yeah,
it means that it's larger than the coefficient. And everything will be garbage, rubbish.
is it the standard error? Is it
So this is important. The first things to look is the error.
yes, more than this,
They are the same
but
fundamentally.
we also take this. This is the a measure of the goodness of fit, no?
It's written below.
Okay, perfect. Okay, and we can have 1 star, 2 stars, and 3 stars that indicate that our p-value is between 0.05 and 0.001. No? Okay, but if
The
you
probability that the coefficient is so small that the coefficient is very significant is very, very high.
yeah,
So is
it's very good.
smaller than, so the mistake that you make is very, very small. So when you look at the some empirical result, the first things is always to look at the significance of the variable. You don't care the sign of the number of the coefficient. You have to understand if the variable is significant, because it can be wrong, can be something else. You should never buy a result which do not have a significant, so a small error.
And so you are telling me that the only thing I have to do, for me that I'm not an economist and I will never be, is to look at the
star.
asterisco.
The
The
stars,
stars,
yes.
which
The
are a
stars
good
of
proxy of the
If they have
mistake.
3 stars, it means your
Very
research
good.
was well done. And if the
Yes.
probability, if you have 1 stars, it means that you are not doing.
Is good, but we should be
We can
careful.
talk about
If there's
Quindi la
no
probabilità
stars,
di errore comunque c'è.
if you have no stars, doesn't mean it's garbage. You can
Yeah.
throw it away. Okay. So, because the problem is that we want to use statistics to understand phenomena. So they try to use statistics to support ideas, to support interpretation. And you have to be sure. Sometimes these errors are small by mistake, because there is other things around. But if they are even wrong, you don't buy the results. And so don't waste time in commenting this result. Okay? You have first to look at this. And the second thing is the number of observations. These are 3,000. It was different if there were 13 Ks. 13 Ks is difficult to have a small error. They should be all on the same line. If we do a study here in the room completely full up with 70 people, you cannot be representative of all the students of the university.
If your sample is large, your
Yeah.
regression is more robust.
But the R square, you explain the R square what is?
So the R square is a measure of goodness of fit, and so
If it is
indicate how
100, if it is 100, is a very good fit. That you control all the variability. With one variable, really is something like that.
consider that R square is a very cheating measure, because so it shows how much part of your regression is explained by your variables, no?
Yes.
But
And here-
but
and
it's a
here-
cheating measure, because if you have a large sample, this is higher. So
But especially if you have a better model with more variables. This is just saying that 10%, only 10%, 12%
10% of your variable,
of the variation
yes,
of wage, no? Monthly wage
is explained by
the
your since
efficiency.
migration.
Only 10%. And because you have such a simple model, you put just one variable, you cannot pretend to have more than 10%.
Yes, but if you had another variable or another variable,
Yes, if you have a multivariable analysis.
yes, this is higher, but is a cheating measure. It's not.
But it's a variable that explains the effort that you put in explain the variation of a phenomenon. And however, sometimes works, sometimes don't. And sometimes you put other variable to increase the square, but this variable has nothing to do with the phenomenon. and so they don't contribute to the explanation of the phenomenon, are in a certain way important because especially the young generation of econometricians that don't like to study, they put all the variables that they found in the data set. This is the worst thing that you can do, but many people doing this. If you put all the variables, the number of dogs, cats, to understand the heights of people, in addition to age, if they have a dog, a cat, if they went to school, if they have brother, sister, and so on. Of course, this variable increase for sure the R square, but randomly but not so much, because they're not related into a model. If I put instead only the heights of the parents, of the mother, of the heights of the brother, these are variables that explain your heights, not the number of dogs or or if there is a relation that tall people, short people have a dog or have tall people, but we don't know this. Okay, so you have to be very cautious, serious, try to find relationship and so on.
Okay.
10% is not bad. 10% of the variation of wage is explained by years of variation. So it is very significant. So this is one every year, 13 euros.
Yes, 1 year, yes. Each 1 year, 30 euros
Yes.
on wage. Okay. So this is the interpretation. Okay. Take a look at this multivariate regression. Okay.
But you are always insatisfied by the explanation with just one variable.
Yes.
And you want to do
In this case, we have two independent variables. Okay, so this is the dependent variable, our outcome. This is the beta zero, as we said, the intercept. This is the slope. This is the other slope, but this is the slope of this variable and the slope of this variable, and this is the error. The result is the same.
You have the coefficient.
Yes.
Yes.
You have
the coefficient.
at individual level, so for each person, and yes, for each person, for instance, no, or for each firms or a firm, or for each region. Okay. So, how to interpret the coefficient? Beta 1 provide the effect of 1 unit increase in all x on all y from average out the effect of x2 on x1. Beta 1 provide the effect of 1 unit increase in all x1 on all high from averaging out the effect of x1 on x2. Beta 0 provide value of y when both independent variables are equal to 0. So the intercept. The intercept.
No, it's not the intercept because you cannot do graphically anymore.
Yeah, but if you remember, we have just one variable, but imagine that it's very similar, no? The situation. This is beta 0, okay? And this is beta 1. Okay.
Until two variables, you can use a cube. You have on one side one variable, and on the other side the other variable. But it's very difficult to represent. The more variables you add, the more it's impossible.
Let's go back to our main regression, the table regression, yes. So we have here since migration, but also the total hours worked. In this case,
as explanative variable, month, gross.
yes,
wage.
is the same regression, but in this case, we have the effect of both an increase in years since migration and total hours worked on the foreign gross monthly wage. Okay, as we said, one here in the host country increase the wage of 30 euros. Okay?
As before.
Yes, as
Is significant, the standard
Is-
error is very small, 0.7, the
Yeah, it's
coefficient is
very good.
13. So
when we had another variable, we see that an hour work per person increases the wage of around 10 euros. Okay? The R square is higher because now we have two variables and maybe our main relationship is better explained by our
yes,
variable.
you see, the more variable you add, the more the
Yeah.
square increase, little by little. You need, however, to have a model in your mind, so you cannot insert any other variable. If you had, for instance, education, you will have also another effect. But the result is very interesting because the coefficient of years in migration doesn't change so much.
Yes, doesn't change.
It was like this before, and it is like this later. And this is very important because you should add variables which are among them independent. You cannot add variable which cause the other variable. The two are for sure absolutely independent. So the two are explanatory variable of the monthly wage.
And also it indicates that from an economic point of view that the length of stay is very important for the wage of immigrant, no?
The migrant.
Yes, for the economic assimilation of immigrant. Okay. So the interpretation is okay. This figure shows the relationship between education and wage. Okay, so we have the age and we have the wage. Okay, this figure, so in general, the age is a good proxy for experience, no? So, and this figure show us that for higher age, no, the wage increases. Okay. This
There is
figure
the
of
theory on the job training,
Yeah.
you are working, you get experience, you become more professional, and this way your wage increase. But this is not only, so the wage profile of people is starting low, it is increasing through life.
Yes,
Only
because-
when you are close to retirement, your human capital that you accumulated on the job is declining, and so the wage do not increase anymore at the same speed. Because the human capital theory telling that you accumulate a lot of human capital, but a lot is old. For instance, the people like me are less proficient than the young with the computer, with all this problem and so on. I spend 15 minutes more than my colleague to settle all the things and so on.
Yeah.
And this is just an example, but also in many other fields, there is an aging of the education. But here, the picture, in addition, Roberta, what
So-
is showing?
Another thing is that the solid lines is our regression, no? Our fitted, so
Ma spiega prima
profile.
l'altra, spiega prima l'altra.
Spiega.
The data show the actual profile, and so there is this profile, but this profile are different according to the level of education. So if you
Yes,
have
because we have the
16,
age that is a proxy for experience. So for
but yes,
education.
but fundamentally you have people with 16-year education and they have a higher profile.
Yeah.
They enter in the job with a higher wage and they remain up there. the people with 12 year of education, they have higher profile start lower, but little by little increase remain there. And the people with 10 years education, of course, is much lower. It's more mobile, as you see. The lower is the level of the education, because you can be very clever and learn very easily, so it's less flat. So this is the actual data.
Yeah, consider exactly. Consider that this is the actual data. So the data that we observe, no?
Mm.
But the fit profile is the solid line that approximate the actual data. Okay.
But with, you see, with
So-
the actual data, you don't go too far. We want to find a relationship. So we want to fit with data to have forecast, to have an analysis, to understand more. And the fitted line is try to mimic the
Yes,
relation,
and-
but in a linear way.
For
Not
instance,
going
take
up
a
and
look
down.
here. So here we have a huge error, no? Because the
Variability.
fitted line is not able to.
Yeah, you have a lot of
Approximate,
variability in the
yeah.
data. This make it more difficult to
Yeah.
fit, while it's very
better
easy
it-
here for
That
this
is,
group.
That is
The
education
interpretation
10
is very
years.
easy. Is on the data. The error is very small, just a little bit here. Here you have a little bit of error here, there, so on, but they fit here is a pain in the neck. When you have a data like that, it's really difficult.
Yes, why? Maybe because for the personal individual characteristics, no?
Because the lower is the level of education,
Yeah.
the more the personal characteristics are important. If I take all people with a PhD, more or less the people that arrive to get a PhD has been selected and are more similar.
Yes.
While instead for 10 years education, the people are still their own, with their own characteristics. They are more heterogeneous. So there is not a selection in education. And you see me that from 10 to 12, 16, this is the cleavage. Because after 12 years education and 16 years education, the people are forecastable. You can forecast the relation between education and age. While instead, if the people has low level of education, is the human capital, their ability is strongly embodied in the person and also in the technology, because the more they become older, and you see, you still have this up and down. I will never like to work on this data. I will change project if I have data like the last one. They're impossible. Because theory doesn't.
Okay, this is the comment. Okay, another table. So this table shows the effect of an increase in the education level on different labor outcomes. Okay, early earnings, hours per week, weeks per year, so on.
Annual
Hours and
annual.
annual earnings. Okay, take a look. The red circle shows the increase of 1 more year in the education level on wage, which is 0.1 log, that is 10%. Okay? So,
It is significant or not? It is significant or not? Now you know very well. It is significant star are not there in purpose. We have omitted star because they wanted the answer from you. It's not significant? No. Why not? You cannot see. Okay, here is 0.100. And here is 0.001. What does mean?
The error is very low.
Very small. So the variable is significant. This has 3 stars. If you don't have stars, look at the error.
But we don't say that often we can find this and not the star, for instance. No.
Yes,
Yes.
they will find the stars. So
Yes.
we can
Yes.
ask for them.
So the blue circle is the standard error. So as we said, it represents the average distance that the observed value fall from the regression line. Okay, it tells us how wrong the regression model is on average using the response of the using the unit of the response variable.
So the explicative variable is hourly wage in the first
Yes,
column.
yes, yes.
And
Now I
1
can-
year of education is providing 10% increase in wage.
Yes. And finally, the R squared that, as we said, is a statistical measure of goodness that show us how much, how well our model fit the data. So
E look at the women.
look at the women.
Ripeti i coefficienti perché non li vedo.
So for the women, the situation is very similar. So because the increase is 10% like men, practically.
Yes, the error is the same.
The error is the same, and R square is lower. In this case, our variable explain in a better way our
Male wage.
yes, the early wage respect to women, no? Okay, the situation is practically very similar for the other column.
No, it's worse, not
Yeah, it's
similar.
worse, but
It's not similar, it's worse.
This is similar. This is very similar. This is 14%. This is 4%, 2%, practically 2%.
Yes, but for log hour wage per week, the R square is just 18%. So the significance is limited and the effect is 2%, so very small. If you take log week per year, the R square is 14, so they explain just a little of variation. The coefficient is 2%. So you better try to find something else as a model. For the annual hourly wage, you have 4%. The significance increased a little bit, but still 20%. Is much better if you go to annual earnings. At that time, the R square is 40%. So this simple value level of education explain a lot. And the effect on the coefficient is 14%.
So what this table tells us is that the education is very important.
Is
As
important
determined
more for male.
more for male than women, even if the results are very similar, no?
Yes.
And maybe for the, I don't know, I can hypothesize for the long-term position, maybe, no?
For the annual wage is
Yes.
much better than for
Maybe
the...
for the long-term position, I don't know.
But why the R square is much lower for women? Because the wage equation of women is made by many other variables. No? The number of children, where they live, the type of jobs, and so on. So that reason, you see, the numbers are boring, but if you learn how to read them, they speak so much. Because I am old, but I'm able to stay hours looking at data. Also descriptive data, because the data speak, tell you the story that there is behind. I try to convince you. Yes, please.
And could you also make some hypotheses for what concerns the fact that for men, the spread is so different between hourly earnings and annual earnings, and for women it is the same?
You see, for women is lower. That means that other variables are important. While for men, we are speaking of education, the role of education in explaining the wage of men. Hourly and annual are strongly affected by education. There is less variability. Instead, for women, other variables are important, both for the hourly wage and for the annual one. So they don't improve.
Another thing is that, consider that in general, the research include any control to control for any other characteristics that are able to impact on our main relationship. So, for instance, we have cubic in potential experience, an indicator for non-white race. Maybe sample include men and women age who report. So, because we now we see just this, no? But in general, we include other control
For instance,
variable.
territorial control, you have
Yes.
where they are in north, for instance, in Italy, north, south, center, and
Yes.
so on, because the wage can be different also according to the cost of life, the
Yes.
cost of a house, the cost of the
Yes.
bus, cost of a coffee has been taken many times as proxy of the cost of life. Because some prices were imposed by the government, so they were the same in all the country, but some other are in
The
price.
GDP, for instance, if present, no?
Especially if you do cross-country analysis, GDP is always taken as a reference.
Yes. Okay.
But it depends on you now. If you do empirical analysis, you find, but always read the footnote. Because in the footnote, there are explained things that you don't see in the table. In the table, just we wanted to stress men and women wages, and we had already many columns because we had many other variables. But this is done with other control.
Okay. Another thing is that sample size are 1,000, around 1,000 for men,
And they also put in the footnote an important notice that what the economists consider outlier have been dropped. So the wages before $2 and more than $150 have been eliminated. Because sometimes we think it is a mistake or is a special person, they're not part of the sample. If we put them, you risk that they intersect the line that we try to interpolate the data is distorted. For instance, high wage and low wage will be steeper like.
yeah.
Instead, you want to understand the average of the phenomenon, the main driver. And so this is the reason why the economy take off the outlier. Why
Yes.
social scientists frequently, they are more interested in the outlier.
Yes, this, for instance, no?
You see,
Or, no, in this case, no, but this. The outliers.
because the estimate could be steeper just
Yes.
because you have two cases, we distort all the sample.
Okay. This is the comment, okay, the interpretation.
So
Yeah.
the formula was the formula for la linea retta.
See, a linear interpolation. It's we are speaking of linear regression, univariate, multivariate. The linear regression can be improved. You can put a square instead of having linear. But the idea is that it's the simplest way. You can do many other sophisticated things, but the majority.
This is linear, no?
Yes.
This is imagine that here there is one. No? This is linear. If this is square or cubic, the line should be different, no?
Sì, sì.
Yeah, so
Quadratic.
quadratic and cubic maybe. I don't remember. Ok, vogliamo fare una pausa oppure continuiamo? Perché ora
Sì.
c'è la parte, non so se loro fanno pausa.
Lo facciamo a mezzogiorno e un quarto, un'oretta e mezza, vediamo se trovi un punto
E
dove...
poi cominciamo adesso a vedere per esempio time series,
Okay,
panel
now
data.
we move from, you see, the data set are many. The analysis can be at individual level. Individual can be the single person, or can be a state, a region, but a unit. So I want to understand the relationship between the wage and the years since migration of a migrant or the education of a migrant. So as individual, or I can want to study France, Italy, Greece, so I can do the same analysis comparing different countries, states, and so on. Or I can do something comparing cross time to understand the growth of a phenomenon. So now we take a break, we resume in 15 minutes, and we go on with
Ok. An important comparison is between time series approach, cross-section approach, and panel data approach. So in the time series approach, we look at the correlation of variable over time, okay, taking into account a single unit. For instance, the correlation between GDP and investment of a country over time. For instance, for 20 years. In the cross-section approach, we look at the correlation between variables in a given time frame, taking into account several units. For instance, the collection of observation over several units in a given period. For instance, just 1 year.
for instance, the region, Italian region,
Yes.
the wage and the employment in the Italian regions in 1 year.
In 1 year. Or in one period that could include 2 years, no?
Yes.
2 years, yes.
Unit of time.
In general, 1 year. And finally, in the panel data, we look at the correlation between variables taking into account several units over time. Okay? The classical example is what we have, okay. For instance, I don't know. Vediamo se c'è un esempio. This is 1 year. For instance, here, no? Imagine that we have 6 years, no? This is a panel data, okay? So the correlation, the relationship between an increase in years since migration and total hour work on the foreign gross monthly wage in 10 years, no? Or in 5 years. Maybe these data are panel data.
A panel is when you follow people through life, no?
Yeah.
You have a panel, for instance, the German socioeconomic panel is a data set on migrants in Germany and of German citizens, and they follow people through life. So they put together the time dimension, they follow people through life, but they also the cross-section, cross-individual dimension. The panel data are the best, but they're very costly. So that's the reason why we use cross-sectional time series, because it's much simple to
Yes.
have this type of data than a panel.
Yes, imagine to have, for instance, different person here, and here we have different characteristics of person, the age, the
Education.
region, the education, This is a panel data. Single person for different years with reference to different individual characteristics. Okay, time series approach. So,
Which is the simplest one,
yes.
using macro.
Yes. So this figure shows us the relationship between the investment and the government expenditure per consumption as percent of GDP. Okay, so I want to say one thing. One moment.
This is very interesting because as you see, government expenditure in general are substituting private investment or anticipating private investment. The government is building bridges, streets, the water system, so infrastructure, or the private invest and this is a special graph which is showing that when there is a decline of private investment, the state intervene. In general, we had the reverse, the state intervened before and later on the private intervene. Is that this? I don't know which country it is, what bank account, or they say national account. So all the countries.
They follow different direction, no?
Different pattern, yes.
Yes, different trends. Okay,
but it's showing that the state is becoming more important in the GDP. While at the beginning was less or smaller, it's becoming 20% of the GDP, while the private investment are declining. That means the state, the economy of the state is gaining importance for the total production.
And this is the table. So this table shows us the relationship between the government expenditure and the investment, no? This is the graph, and this is the table.
The results.
The results, yeah, defines. Okay, the red circle shows us the average effect of an increase in the government expenditure on a private investment. Okay,
so
in this guy, it's
the
negative.
more the state intervene in the economy, the less the private intervene.
Yes, is negative. The blue circle shows us the standard error, that is how wrong the model predicts the actual data. And we have the green circle, that is the t-statistics that tell us whether we can accept that the estimate is not wrong enough. Okay?
Instead of having the stars, you can have the t-statistics. But
And
for
here,
us, it's just saying...
yes. And here, and is where we can see the star. So,
in a different shape.
this is a previous step, no, of a final table in which, for instance, this is the previous step, previous table of, one moment, of this table, okay? The stars that you see here is...
Well, they're not so much interested in this detail. No.
Is that P,
The star
probability that our hypothesis is good, practically. No, 0, 0, 0 is 3 star, fantastic.
Yes.
Okay, and then we have the R square, so we know
that is fantastic. 60% of the variance of GDP is explained just by one variable.
With zero.
But the more you understand, the more you know the statistics, the more you understand that time series is always provide good fit. You can analyze the number of cats and the number of dogs, and you find strong in time series, you find a strong correlation. So don't be so optimistic.
when in time series there is many other things that change that drive the result.
Yeah.
In cross-section, 10% is fantastic. In time series, 60% is the least. The number of observation,
is
58, nothing, peanuts.
maybe
So you had to be careful
something does work.
on basic theory on this.
Yes. Okay.
On migration, you have also time series analysis, but especially on the migration choice, if people decide to move.
Yes. Okay. When we run regression, a central part of this step is testing the findings. No, some issues are relevant here. So the regression may not fit exactly the data in the linear model. How can we know that independent variables are still useful to explain an outcome variable? And finally, how do we know if we are missing something in our regression, the so-called missing variable, no? So take a look at this figure. Okay, so this figure shows the relationship between the decadal change in immigration share and the decadal change long weekly wage. Yes, so as we can see, so from a general point of view, an increase in the decadal change in immigrant share determine an decrease in the weekly wage from a general point of view. So, but what is important here is that, as we can see, some points in the diagram are very far
from the line.
Yeah, from the predicted line. Remember that the predicted line is the line built on the actual data, so on the observer data, no? Okay, this point say us that our regression does not fit exactly the data in the linear model. If the distance between the line and the point are very far, the errors
very
are
large.
large. Yes, it's not good, for instance.
But
Take
you
a
see, there is come si dice una nuvola? There is
window, no, cloud.
a cloud of points there,
Cloud, yes, cloud is
a cloud of points there, and some point over the other one. So if you don't have this second part, this could be round, could be horizontal. So we should understand well what this part of the data. So the decay change immigration share, if which are the country, now is a single country in the period, in such a large period, and probably a single equation doesn't fit the data.
This is a panel data, maybe, no?
Is a panel, but probably the quality of the data has changed through time. And probably this is not, for instance, I will not buy any result based on this data.
Yes. Maybe the model is not correct.
The model is not correct, there is something different, that means that the policy has changed. If the policy has changed, you have a policy here and a policy there.
Yeah.
And here you have an horizontal line, and here you have another horizontal line. So the descriptive statistics is very important because if you want to find the relation, this should be visible in the data. And here you see immediately that this negative relationship doesn't work.
A good solution, yes, could be to divide the data into parts and conduct two different
analysis, especially go and study.
There is a jump here.
Yes.
Can you see that there is something similar to a jump, no?
Yes, but especially probably there is an institutional change. They change the policy.
Yes.
There was, let us say, if it is United States and this is migration of Mexican,
Probably they make an agreement. Something has changed, or there was a war and people stopped to move. So, but anyhow, the model doesn't fit the data. So
Yes.
even if it is time series, and the time series in general work, this is not the right story.
Yes, yes. So, as a result,
In
as we
Boras,
say,
it is in the United States.
a solution could be, for instance, to add the years here to see if there is
They can change
a
immigration share, but this is the share, not the year. You should look.
Yes, but a solution could be to put here, for instance, the years, no? Because
Well, you
in
want
this
a
case, we can
relationship
see,
in the
yes, we can
dimension
see.
time series. You can see, you should look at descriptive data
Yeah.
to understand what happened.
Okay, so in this case, a statistical check helps us to validate our findings because. Okay. Okay, an important as we saw practically, an important part is how to compute the coefficient. So the formulas, for instance, imagine that this is the Y, weekly wage, this is the X, immigrant share. The formula that we saw is that we saw is also beta 1.
Is the
over
coefficient of
yes,
the
is
variable, and
yes,
this is the intercept.
the same, yes, the same formulas practically. This is the difference between the expected variable, the expected value of y and beta y multiplied by the expected value of x. Same formula, okay. How to interpret the regression? Okay. So imagine that we have this relationship, no? The weekly wage function of the immigrant share, okay? What is important for us is beta 1, that is the coefficient of our main variable. So assuming that the error term has zero mean. Why? Because in general, when you run a linear model, there are a lot of assumptions that you have to do, that you have to assume if you want to run this kind of model, okay? It's not particularly complicated, but it's just an assumption, okay? If you, I don't know, if you is a statistical researcher, maybe it is a problem, no, for you. But we are economists that in general we assume that
Here
it's
at
in this
zero
way.
means, so there is sometimes you are wrong because you are too low,
Yeah.
sometimes you are wrong because you are too high,
Yes.
but they are a little bit on the top of the
Yes,
low.
it's just an assumption. Okay, assuming that the error term has zero mean, so we can say that on average, if the immigration share is equal to 1, salary is beta 1 plus beta 0 plus beta 1. If it's equal to 2, the salary is beta 0 plus beta 1 times 2. And so on and so forth. Means the predicted value of weekly wage are, so, okay, what we have. See. Okay.
So this is very important to forecast.
Yes, yes, yes. Okay, the standard error. We talk about the standard error. So there is a measure that summarizes the deviation of the fitted variable from the true values on average. So an important rule to be sure about about how much good is the standard error is the rule of thumb. If the coefficient, yes, if the coefficient is twice the value of standard error of coefficient, we say that estimate of the parameter coefficient are different from 0, okay? For instance, take a look here. This is around 2 times of this.
0.7 times 0.7, 2 per 0.7 is 14, 1.4. It is much smaller than the other.
It's a good rule. It's not a dogma, but it's a good rule. Yeah.
You should look more the statistics, but
Yeah.
if you want a rapid
It's not a
answer,
dogma.
that means that the error above and the error below should be more than the coefficient. So the error, you are still inside
Yes.
the space of the coefficient.
Okay, some helpful tips. Usually regression tables show star near the coefficient to show how much we can rely on estimates. 1 star is not reliable, but good, in my opinion. 2 stars, reliable enough, and 3 stars, fantastic. Estimate of the coefficient change according to the number of observation. In general, larger is the sample, better is for us, for your analysis, no?
Because if the sample is very large, even the outlier, they disappear.
Yeah.
If I have 10 persons, one is very tall, one is very short, this affects the result. If I have 1,000 persons, if there is one very tall and the other very short, they disappear.
Yeah.
So the larger is the data set, the more I can spread the result that I get.
Yeah. If you imagine, for instance, a normal
To do that,
distribution.
you'll need to be online.
Siri. Sorry.
I'm here.
Sorry. Siri. Sorry guys, but if you have iPhone or Apple, you know Siri. Okay. Okay, so imagine for instance a normal distribution. Do you know what a normal? No.
Okay.
Okay.
A distribution which is
So,
equal
if
on
the-
one side or the other side,
Imagine
with the peak in the center.
imagine yes, collina. Collina.
Just a hill.
Ah, yes, imagine a hill, no? If your sample is very large,
The data
the
distribute
part,
like that.
yes, the most part of your data are on the center, no? On the central part of your distribution.
You have few people with very low wage and few people with very high
Yes.
wage. The majority of the population is in the center.
Yes. And the outlier, as Alessandro said, are very low. Okay. Okay, so what are the main assumptions in a linear regression? So when you run a linear regression, there are some problems that you have to consider, no? So the assumptions are 3. So not omitted variables, full rank, and homoscedasticity.
Non-omitted variable is very clear. If you want to interpret the wage of the migrant, you need education, age, number of children, a lot of individual variables. If I want to interpret the investment, public spending, I need the population, the interest rate. That the model is explaining. Otherwise, one coefficient can be the result of something else which is missing in the model.
Yes. Take a look here, for instance. So, omitted variable bias arises when we don't take into account all the possible variables linked to both dependent and independent variables. So, when you not consider some important variables that is able to influence, to impact on your main relationship. For instance, we can see the relationship between the wage and the experience. Imagine, for instance, that we cannot consider the age, no? So maybe this correlation is spurious, no? Because show something that
Of the level of education.
yes. So an important point here is that this is a linear relationship. This is one, but we can see that some point. So,
Out of this.
yes, maybe there is so maybe the error are large because these points are very far to our solid line. Okay, in this case, probably we have to consider the square of the experience, no? So beta 1 experience at linear level and at square level. We can say as square level. In this case, we can see that the fitted line better fit our data. Okay?
And there is a theory which is saying that the experience is very important in explaining the wage of people. So the amount of years of time that you spent on the job. But of course, the older you are, because here you have years of experience, but you have also the age. The older you are, the more your experience is obsolete because there is innovation, there is other way of doing. Imagine to be an engineer, and you are an engineer is working on car. Now there is electric car, hydrogen car with many other systems, and their expertise become obsolete. So they are less performing, and their wage will not increase. Instead, a young engineer that arrived at expert in electric car, this has a steeper wage profile when they are young because they come from the university, from school with a background, and in 8 years of experience they have a higher wage than the one higher wage, and the one that has 10 years of experience is not increasing anymore their wage because the human capital is
Yes.
more.
Yes. Okay.
So you have to find the appropriate data. Square is always a solution because first of all it's very simple, but what is saying that the coefficient is positive but is declining through time. It's not doing something big. It's simply changing. It's not linear. It's not the same for all the level. It's not the same for all the wage. It's something subtle. And if the negative, so it declines, so it is growing, but at a lower pace. And that means that the first coefficient is positive and the second is negative. In some point, the second negative is larger than the positive one if the experience is very high because the wage decline. So it's a very flexible tool, the square, to adjust the relationship to the event. You can have a negative linear, the negative coefficient and a positive square, or vice versa, a positive one and negative one, if it is like this, or
Yes,
if
it's
it is like this.
This is linear.
Yes.
This is.
But this is the experience square is negative. But you can also have the other way, the
Yeah,
one
yeah.
negative after increasing. So it is very flexible
Yes.
and not complex.
Okay, at the beginning of this school, we talked about the difference between correlation and causality, no? Okay, sometimes researchers use causal inference to evaluate public policies. For instance, an increase in health expenditure, increase in unemployment benefit, and so on. Okay, evaluating a public policy requires another status of the world where there are two different but similar group of people, treated people versus not treated people, in order to compare the two outcomes. In the real world, it's impossible to have both. Therefore, researchers use different samples with the same characteristic to evaluate the causal impact of a policy. An example in this case could be the healthcare expenditure. No? Okay, the correlation between the healthcare expenditure and the level of health might be negative for the presence of reverse causality. So the reverse causality is a big problem because
You have a theory behind each regression. It is the health system or the health expenditure that reduce the health, or is the negative health that demand an increase in expenditure? Which is causing what? This is an example of health, but we have many.
For instance, no? Um,
Sick
As an
people spend
yes.
more on health.
Might be negative. So the correlation between healthcare expenditure and the level of health might be negative because people spend more on healthcare. No? So
While
another
you will
example,
expect that instead
yes.
higher expenditure on healthcare reduce the mortality, reduce the disease in the population. But the relationship can be.
Yes, another example could be, for instance, I don't know, imagine the relationship between the value added of the firm and the number of workers, no? Immigrant workers. So if you run a regression, you can find, for instance, that the firm that employ more immigrant workers present an higher value added. But maybe the firm that employ more migrants are bigger. So this is a reverse causality because you don't catch the effect of migrant worker on value added, but you catch the effect that the firm
that higher migrant has higher
are
value added.
bigger, no?
So it's not a causal.
So it's for me is an important problem, the reverse causality, in order to do a good research, no?
Absolutely.
Okay, in this case, in the healthcare expenditure, a solution could be a public intervention targeted to a specific group that may solve the reverse causality issue by comparing the level of health before and after the intervention for two groups. Imagine two groups, treated versus not treated group, and a specific public intervention in the middle. Now, you can test the intervention, the public intervention, the public intervention, yes, correct, before and after. Okay.
Yes, imagine that the state decide to have a presumption, an intervention, try to vaccinate a group of people.
Yes. Yes, very similar
And
to a biology.
Another,
Very
yes,
similar to
another
biology,
group
medicine.
instead is not vaccinated. So you try to understand if these people are better off
Yes.
later on
Yes.
than the other. You need a counterfactor. You need another group that is not treated, so is not receiving the same treatment.
Yes. Okay, since only one group is affected by the policy, we can compare outcomes to see whether an increase in health expenditure increases the health of treated individuals. Okay. Another interesting example is the unemployment benefit. So the correlation between unemployment benefit and the probability of finding a job might be negative because unemployed workers are less likely to find a job. Reverse causality. Maybe, I don't know, for the personal characteristics, no? Okay, also in this case, a solution could be a public intervention targeted to a specific group that may solve the reverse causality issue by comparing the expenditure before and after their intervention between two groups, treat versus non-treated group.
So the intervention could be a training course, a support in finding a job, and another group in which the intervention is not done.
Yes, you can also just look at the different, I don't know, at the different employment situation between two groups before and after, no?
Yes.
Just to see if there are some differences, no? And then you can decide to run a more complex analysis regression. Okay, also in this case, even in this case, since only one group is affected by the policy, we can compare outcomes to see whether an increase in unemployment benefits leads to higher probability of finding a job. Okay. That's all.
And especially it's very difficult because many other policies take place. So it's very difficult to understand if the unemployment benefits are causing, are increasing the possibility of finding a job, because with employment benefits, probably people are made in contact with this institution which favor that inform them about the job available. So it's not the unemployment benefits, so the money that people receive, but the support that they receive in finding a job. You remember the reddito di cittadinanza in Navigator. The reddito di cittadinanza per se is not increasing the probability of finding a job. As the Navigator, the agency, they should help them in finding a job. So the problem is to find appropriate instrument to measure the effect of a policy.
Esatto. Okay, that's all.
Okay, this is a fresco. Tomorrow we go on, try to look many results, but the idea is that today we were looking analysis, the relationship between variables, how you should look at them. It is important to have a large number, so the results should be statistically significant, and should be important to explain a phenomenon. So you should look at the R-square to understand how much the model, the test that you have is explaining the phenomenon, and you should look at the coefficient to understand if the coefficient is statistically significant. If it has no star of the error is very large, you should change model. Of course, the result that in general you see on books and on international publication are traditional results. So the model in theory is good, but not always provide sufficient answer. And we also look at the analysis can be done in many dimensions. You can do a time series analysis, so you follow a person through life. Like if you want to study integration, you need a time series analysis. You should follow a person through life. It's not something that you can study cross-section. Sometimes it's done, but it's not. If you want to understand if somebody that is staying in the destination country 1 year, 2 years, 3 years, 4 years, 5 years, 6 years, is able to integrate. So is able to find a job, to find a house, to speak the language, to work, to enter into the society destination. Unfortunately, these data are not always available. So what you do is a cross-section. You try to compare people which have different seniority in the country of destination or different regions. Depend to understand, for instance, the policy. You use time series instead when in general you want to study the migration choice. You remember the studies that I was showing you last week, in which we want to understand why people move. If people move, and we have average data, we don't have individual data, you have the number of migrants. So we have many countries, the number of migrants, and we have the variable of the wage in the country of origin, the wage in the country destination. We have the distance from the country or between the country origin destination. We have the linguistic distance. You have if they have a common border, if they have well, we coming from former colonies, so they were speaking the same thing. All these variables, but we don't do this just one person. We have the average number. So the amount of migrants in one country, and we do a time series analysis. We have the information on many years.
We will talk about the migration choice tomorrow. And the other important topics in the migration economics.
I was mentioning this because already we have seen.
Oh, okay.
And we have just average data. So we know how many migrants coming from Morocco, how many migrants coming from Tunisia, how many migrants, and you can put in the multivariate analysis different variables referring to the different countries, to the different nationalities.
Okay, if you have any doubt, you can contact me. There is no email, but
But tomorrow she will
Roberta,
be here.
Punto,
She will be here, so she will put her mail in
yes,
the last
Roberta,
slide.
point Misuraca at unito.it. Very,
You put it at the end of the next slide.
yes.